Great. Thanks for the introduction. My name is Burton Levine. You heard a little about RTI, the organization I work for. I'm a sampling statistician. I've been working in the field since 1999. And I call RICS, and I'll repeat what it means, redirected inbound call sampling. So I actually came up with the term inbound call sampling because it's opposed to an outbound telephone sample, which is a standard for some industries to do outbound telephone sampling. It's a probability sample. And so in this case, the calls come to you, the user initiates the calls. But in outbound telephone sampling, you may call somebody up and they can't participate and they are given a number so they could call back later. So that's an inbound call. So to distinguish that, we added the qualifier redirected. So I call this an emerging fit-for-purpose non-probability telephone sampling design, but you'll see emerging, I may use a new adjective, burgeoning, because we're making more traction and testing it in more situations. So this is sort of an apology. So my background is in probability sampling. My expertise is in telephone sampling, but I also do something called address-based sampling, where you use a frame from the addresses that the post office delivers sample to. So everything I'm going to compare is to probability samples, and I suspect people on the call might have more experience with web surveys, but that's not my focus, and I kind of apologize. But it's applicable to your world too, to the web survey world, and I'll try to interject some information about that. So this slide comes from a presentation I did for the Federal Committee on Statistical Methodology. And so their problem, that statement came from their literature. But so we all have a similar need. Organizations need to provide objective, accurate, timely information that informs decision making. So in the fields that I work in, it's mostly public health surveillance, and state departments of health might conduct surveys to decide whether they should raise cigarette taxes or something like that to prevent illness. But you need decisions to make business decisions or marketing decisions. And this is a quote from that Federal Committee of Statistical Methodology. Continued reliance on traditional, what they mean is probability sample surveys as the principal means in collecting statistical data is threatened by increasing difficulty and cost in conducting the surveys, with consequent threats to data quality and by increasing demand for more and faster information. So basically, in the field of probability samples, people have been seeing declining response rates, which has two terrible problems. It increases costs and it causes non-response error, which may result in non-response bias. So I've been working in telephone surveys for a long time, and I've continually heard, about the death of telephone surveys, and I always laughed it off. But now 44% of all phone calls made in the United States are spam calls, and the telephone companies and the phone service, there are apps that people put on their phone, which is doing spam blocking. So a lot of times the calls from the data collection centers are being identified as spam and not allowed to get through, which is really wreaking havoc in both the response rates and bias in outbound telephone surveys, for example. Well, this is where RICS comes in. RICS is a potential solution to the problem. So RICS has several types of implementations, but in some of the implementations, it's a very low cost. So if you don't do outbound telephone surveys, you probably don't know what 1/10 the cost of a complete in an outbound telephone survey is. But in some situations, you could collect data for about $5 to $7 a respondent. It's quick. You could collect data on thousands of respondents a day, and it's low burden because you don't call the potential respondent. They're actually calling you. So as Scott mentioned, they come from people making calls, and we separate calls into toll-free numbers, which have the area codes in that graphic below. And the other types of calls, all the other calls are called direct inward dialing, and most people know those as toll calls. So far, all of my research, or almost all of the research that I've done, have been using the toll-free numbers. Toll-free numbers have the characteristic that they're non-geographic. So people from all over the country dial Bank of America's toll-free number. So you're getting people that's nicely distributed across the country. But if you have a toll number that's to a local area code, it's going to be skewed to people in that area code. I am currently waiting for data to evaluate using direct inward dialing to make estimates from survey data, but that's not ready for this presentation. So RICS data collection methods, there's several options. So the bread and butter, what I've tested the most of, is strictly interactive voice response system. So this is just a totally automated system where somebody dials into a number that's controlled by either Scott's company or another company. They redirect it to a data collection system where you screen, recruit, and then collect the data. So we'll have to ask, for example, if they're an adult, because there are all sorts of requirements of collecting data from children. So we screen out children, and then we get them into the survey, and then the people who respond, they can either respond by keypad or voice. So for example, with the screening question, you might say, if you're 18 or older, press 1. If you're 17 or younger, press 2. That's an example of keypad data collection. You might say, if you're 18 and older, say yes. If you're not older than 18, say no, or something like that. That's an example of collecting voice data. We call that conversational IVR, and there's a system behind it that turns that voice data into text. Another method, and interactive voice response is the cheapest and the quickest, but it suffers some issues with the length of the instrument is limited and the complexity of the questions are limited. And there's also issues with possible measurement error. I've tried to go from IVR, Interactive Voice Response System, to web, and what you do is they call in, you get them into an interactive voice response system, you screen them and recruit them by asking their consent to receive a text message with link to a web survey. If they consent, you send them the text message, they click on the link, and now they're into a web survey that they can do on their smartphone. There are some issues here with the telephone companies recognizing that as spam and not allowing that through. The yield rates were relatively low. This is a work in progress to understand this technology to bring up the yield rates. So the other method, and this is something I just tested recently and it worked pretty well, is live interviewer. So outbound telephone surveys use CATI data collection. CATI stands for Computer Assisted Telephone Interview. And so here, normally in an outbound telephone survey, interviewers are dialing out, and there are rules about dialing cell phones that they have to be hand dialed. You can't use a machine to do it. So they're dialing out, and then they're trying to recruit people and calling back. And with RICS, what you do is you take the inbound calls, you screen them for eligibility, and send them to a data collector. The same CATI data collector as the outbound telephone. And what you do is, the reason why this is such a big cost savings, it's a lot more expensive than IVR because you have your own costs of the data collectors. But compared to outbound telephone, most of the time, believe it or not, is spent actually trying to recruit people. So it might take 4.5 hours per interviewer, 4.5 interviewer hours to get it complete if you're outbound, but with inbound, we could bring that down to 1 hour. So you save yourself 3.5 hours of interviewer time trying to recruit people into the survey. So redirected, I'm switching gears a little bit here, redirected inbound toll-free calls is commonplace. So Scott didn't come up with this idea. I did a study where I was curious about this. I randomized telephone numbers in the area codes you see in that table, and in each one I called 126 numbers at random, and then I saw if they were redirected. And you could tell if they're redirected. Here's an example of one. They say, if you're 50 or older, press 1. If you press 1, they'll try to sell you a medic alert device. If you press 2, because you're not 50 and older, then they'll try to sell you insurance for car repair. So it's obvious people use redirected calls for telemarketing. And so in the 1-800 space, there's 29% of the numbers were redirected. Across all of the area codes with the toll-free numbers, 9% of the numbers were redirected. So if you do the math, it turns out that 4.5 million toll-free numbers are redirected. So Scott's contribution isn't the redirecting part, it's applying this to population surveillance or to collect survey data using this methodology and not just trying to sell people. So what we're seeing on this slide is I'm showing off all the studies that I've done. So I have the completed studies, the studies in progress. The things in red are my evaluation studies, and the things in black are the studies that were paid by government organizations. You see New York State Department of Health, New York City Department of Health and Mental Hygiene, the Florida Department of Health. They're all clients that paid for RICS surveys. So the first study I did was one in September 2015. BRFSS stands for Behavioral Risk Factor Surveillance System. So this is the largest cross-sectional telephone survey in the world by a lot. So they've been doing it for over 20 years, and they collect like 120,000 interviews a year. Every state does it. Anyway, what I did, Scott called me up and told me about his new method. I said, great, let's try it. So I duplicated questions from this telephone survey, and it worked really well. I was concerned that the telephone survey had bias because telephone surveys have low response rates. So I wanted to evaluate it by using a more gold standard study. That's that NHIS evaluation study. And I'll talk more about it, but the bulk of this talk will be the results of this evaluation study. On this slide, these are my future studies, and the reason why I call it I'm going from burgeoning to blossoming is because these studies are already funded and they just haven't happened yet. And the amount that has been funded is dwarfed all of the studies I conducted to date. So I actually have more in the pipeline than I have already conducted. So the NHIS, and you can see from the second set of text that it's the National Health Interview Survey. So this is an in-home probability sample that's conducted yearly, and I think I used the 2016 version of the adult sample. And so I mimicked questions, or I did my best to mimic questions. So it's an in-home person. You'll see the spoiler alert is some of the questions I couldn't ask the same way. So I think some measurement error in there. Now, the results that I'm going to show you, the part of them, much more in depth, have been accepted for publication in that APOR journal, which Scott mentioned. APOR is my home professional organization and the home to a lot of survey statisticians. It stands for the American Association of Public Opinion Research, and their journal is called Public Opinion Quarterly, and this information will be published in the summer version of the journal, and it probably will be on their website in a month. So it's a long, arduous process to get in there, but we're almost there. And so we recruited inbound callers to complete the interview with an IVR system. And so we collected data in two separate one-week periods in 2017. We recruited 138,000 inbound calls, and we ended up with slightly less than 95,000 respondents. We could have even done this quicker, so this is very rapid data collection, and I kept it in two one-week periods because I wanted to avoid having a day of the week bias or the time of day bias. So I wanted just a solid 1 week block. And as Scott mentioned, we collect data 24/7. The APOR 4 response rate was 7.7. Now, I don't know, some people might say, well, that's really low, but in telephone surveys nowadays, that's basically what the response rate is. So it's duplicating telephone surveys, and a lot of people, when they hear that, are shocked. They know that in telephone surveys for the BRFSS, for example, their protocol is to call a household 15 times before they give up on it, unless they have a hard refusal or find out it's a non-working number. So in RICS, there's one opportunity to collect the data. They call you. If they hang the phone up, that's it. And even so, we get a similar response rate as bothering them for 15 times. Now, the difference is in RICS, they're calling you. They're already on the phone wanting to speak to someone. They just thought they were going to speak to someone else. When you do an outbound telephone survey, if they were on the phone, you'd get a busy signal. So they're necessarily doing something else. So it's more burden, there's more disturbance. Also, an IVR system conducts the interviewer quicker than a live telephone interviewer. So the 27 questionnaire was conducted in a medium interview length of 5 minutes. So here I'm showing the unweighted distribution of the respondents. So one way to see if we're mimicking a simple random sample would be to look at the demographics of the respondents. And if it was a simple random sample, they should match within sampling error, which is very small because we have 9,500 respondents. But you'll notice the red is the population statistic calculated from the census, so that we're pretty certain that's accurate. And the dark blue are the RICS values, and the light blue I put in the BRFSS. And again, there's 128,000 respondents in the year that I used, and so you get a sense. So there's some context. So compared to a probability telephone survey, how far off is this? If you look over here, so basically for the telephone sampling, and as I bragged before, I've conducted over 100 telephone samples. I always look at this. You always, in every outbound telephone survey, you get too many older people and not enough younger people. But it's much more balanced with the RICS. All of the RICS surveys I did, you get too many African Americans. That's still a kind of a head scratcher, but you get more African Americans in the population. And this is very unusual. Every single telephone survey I've ever done, outbound telephone survey, was skewed to having higher educated. And you have very few less than high school education. The RICS actually skews in the opposite direction, which is it's very interesting. And here's one of the reasons why this is happening. So in a lot of data collection methodologies, like an outbound telephone survey, you could only collect data between 9 a.m. and 9 p.m. If you call someone at 3 in the morning, it's inappropriate. It's unethical because a lot of people are sleeping. But it turns out in the RICS survey for this NHIS evaluation study, 31% of the respondents answered outside of normal data collection hours. We call these respondents night owls. And so we can evaluate, are the night owls different than the daytimers? Now, these graphs are similar to the other ones, but there's a different meaning. So the red is the population as before, but now the blue are the RICS night owls, and the light blue are the RICS daytimers. And on average, compared to the daytimers, the night owls are more male, are younger, are less white, non-Hispanic, and lower educated. These are all the groups that are underrepresented in outbound telephone surveys. So I stumbled across a very interesting result. It turns out that we're biased because of the time of day that we're collecting data in some of our data collection methods. And the RICS doesn't have that problem. So this slide's talking about, well, how do you calculate sampling weights, especially for a non-probability sample? So this is very different than a web panel. In a web panel, you can't make the assumption that the sample mimics a simple random sample, which we do here. And I'm going to show you in some subsequent slides how we evaluate that assumption. But for now, just leave it to be that we assume that the sample mimics a simple random sample. So we create base weights, which are equal for all sample members, that are the ratio of the population total divided by the respondents, and then we calibrate those to the demographics. Now, you might have heard the term raking or proportional iterative fitting. Those are all subsets of calibration. So in this case, I calibrated to sex category, age category, race, ethnicity, educational attainment, and census division. I'm not going to talk about the special type of weights called delete jackknife. That's more for statisticians. So now we have our weighted data and we can compare our estimates. So ultimately, we wanted to examine bias. My goal was to examine bias by having the NHIS, which is an in-home person data collection with 33,000 respondents. And so it turns out that if the questions are simple or binary or categorical, meaning that they have different response categories, the second one, smoke every day, some days, or not at all, those are 3 categories. you came pretty close. There wasn't a lot of difference between the NHIS estimate and the RICS estimate. Now, to give you the context, the NHIS is in-home data collection. I don't know what their costs are, but it's certainly more than $500 per respondent for them to go all over the country and to go into someone's home and get a data collector out there and to conduct the survey. It's more than $500 a respondent, where the RICS survey is in that $7 area per respondent. So it's apples and oranges in terms of cost, but in terms of the results, they were pretty similar. Things weren't as rosy for the continuous values because we found in this implementation, we learned some lessons. And what we found is at first we asked people to put in how many hours of sleep did you have? Use your keypad to put in how many hours. And people weren't using the keypad correctly. So we had to categorize everything. And then we created questions that were different. And so we have some lessons learned, but the continuous outcomes didn't work out as well as the categorical outcomes. Something else we examined is something called the primacy effect. So in RICS and in IVR, you have some implementation decisions. One of them is to not allow what we call barge-in. So in this case, the question is, if you get sick or have an accident, how worried are you that you'll be able to pay your medical bills? And in one ordering of the response categories, we say, if you're very worried, press 1, somewhat worried, press 2, not at all worried, press 3. Now, if you press 1, it stops the question and goes to the next question. That's called a barge-in. And because of this barge-in, we believe there's this primacy effect. So people are more likely to press the first response option because they don't want to wait around for the third one. And the reason why we allow barge-ins is because it makes the instrument go quicker, it's less burden, there's less breakoffs. So we can disallow barge-ins and make people listen to all response options before they answer. So that's, again, another lesson learned on this study. So the recommendations we had after doing this evaluation is to allow continuous responses, and we could do that using the conversational IVR. We could allow voice responses. I didn't give the data here, but another thing we looked at was item non-response. So RTI requires that I go through what's called an internal review board to evaluate the study for ethical concerns. And one of the things they require is that people have an option not to respond to any answer. And so what we did is in every question, we gave a response option. If you prefer not to answer, please press 4 or something like that. It turns out that there was a high item non-response, and a better way to implement this, or a way with less item non-response, is to give a global prefer not to answer prompt. So in the beginning of the survey, you can say, if you prefer not to answer any question, press star, and leave it at that. What happens is that drastically reduces the item non-response for all but the first question. So on the first question, we learned we put what we call a softball question, a question where you don't care about the answer. So an example of a softball question is, do you consider yourself a helpful person? Press 1 if yes, press 2 if no. And then you don't care, but you give them the option to press star and to get their prefer not to answer out of their system. Now I'm moving to another set of studies and another idea. So this is where I'm going to evaluate that assumption of the simple random sample assumption. So what you're looking here, and I know it's very confusing, but I'm going to boil this down to a single number. What you're looking here is in red is the population. The 3 blue studies are 3 RICS studies. They're called the National Adult Tobacco Survey that I sampled in contiguous years. And I've also conducted the National Adult Tobacco Survey as an outbound DFRDD, stands for dual frame random digit dialing survey. And so this enables us to learn a lot of things. For one thing, you can see, is our RICS surveys repeatable? Because a lot of people are interested in making estimates over time. And the answer is yes. They're actually pretty darn repeatable. And then this also compares the population and gives you the dual frame, the outbound telephone survey as a comparison. But how do you make sense of 5 distributions at once and they may be correlated? Well, I came up with a metric I call standardized calibration adjustment index. And I don't want to get too deep into the statistical weeds. But what this does is it boils the difference between the respondents and the population down into one number. And you calculate your design weights, in this case, with the simple random sample assumption for RICS. In an outbound telephone, you might have strata and disproportional stratification. You could account for that in the design weights. And then the analysis weights are the weights where you calibrate the design weights of the population total. And so what the SCAI, or the Standardized Calibration Adjustment Index, is simply the sum of the absolute value of the difference between the design weights and the analysis weights over the sum of the analysis weights. And then you multiply by 100. It's what percentage did you have to stretch the weights? What percentage of the total weights? So you divide by 2 because when you change the weights, some get bigger, some get smaller. So you're double counting the stretching of the weights. So the more you have to change the weights, the more off your sample was from your population. And it has a very nice interpretation if you simplify. If you calibrate it to one distribution and had 2 levels like sex, and in this example, there's 50% male in the population. If your design weights had 30% males, then your SCAI would be 20%. So 20 or 20, the 20 is the percentage you had to adjust your weights to make it match up. So that gives you a kind of heuristic to understand what's going on here. So now I'm going to apply that SCAI measure, but I'm going to look at 3 different types of surveys, and each one I have 3 different studies. So the one in orange on top, that's all the New York State Adult Tobacco Survey, and this was done with an ABS frame. ABS stands for Address-Based Sample. So this is a frame of all the addresses that the U.S. Postal Service delivers mail to. And then the mode, PAPI, stands for Paper and Pencil Interview. And then we had web and PAPI. We did both. And then we calculate the SCAI and take the average. So for the ABS, the average SCAI is 26.6. So you miss your population because the people who respond to mail surveys are different. They tend to be higher educated and older and more female. So now we look at the blue 3 studies. Those are the outbound telephone surveys with CATI data collection. And here, when you average the SCAI, you get 18.5. Now, the purple are the 3 RICS surveys. So this includes the assumption that there's a simple random sample. Now, if that was false, certainly it's not 100% true, but if that was causing a lot of bias, we wouldn't expect the respondents to look like the population. Now, remember, this isn't like web panels where they're using quotas to force it to look like the population. This is organically what we get from the sampling procedure. So the average SCAI is 20.5, which is a little bit worse than the outbound telephone survey, but quite a bit better than the ABS. To me, that's a very heartening result for this methodology. So now I'm switching gears again. So that was sort of like a validation of our simple random sample assumption. So what I'm talking about here is this pilot that I've done. Other people have done this, but it was recently I conducted my first IVR-to-CATI. And this was for the New York Adult Tobacco Survey. It was paid by the New York State Department of Health. We used RICS to screen the calls, and then we sent them to the telephone interviewers. So when you do outbound telephone interviewing, most of the interviewer time is actually dialing out and trying to recruit people. So it takes about 4 to 4.5 hours of interviewer time to get one completed interview, but the interview only takes 25 minutes. So they're spending most of the time recruiting people. With inbound calls, since they don't have to make the outbound calls, we could bring that interviewer time down to, in the first iteration, 1 hour per complete. We think we could do even better than that when we iron out some problems. So this is a huge cost savings. And I don't have the results here, but I'm going to evaluate the results of eventually. So what is RICS good for? It's good for some things and not others. We use its term fit for purpose. So when is it fit for purpose? Well, IVR data collection is good when you have a short instrument. If you have more than 35 questions, people break off and then you lose people. So after around 35 questions, I found about 20% of the people break off. So you don't want to go much longer than that. You also need simple questions. You can't ask questions with 100 words in them. You really want to have simple, straightforward questions. So if you have very complicated survey questions, that might not be the best strategy for you. So also, this system targets by area code. So if you have a geography that is comprised of area codes and states, all the states are, then it's a good fit. If you want to go to areas that aren't comprised of area codes, that are either smaller, or split area codes, you're going to have to do some screening, and it's going to cost you a little bit extra. So here's just some examples. Somebody else, a competitor, did population surveillance of people fleeing Hurricane Harvey. So there's some metadata on the file, and you have an indication of what county they live in, and now that has the same level of accuracy as the outbound telephone survey, but you could still target by that. And so we targeted, or I didn't, somebody else did, people who were in the areas hit by Harvey, and then they surveyed them. And that actually had one of our highest response rates I've seen from a RICS survey. People were happy to do that one. I thought a great application would be surveillance of gastroenteritis. I still thought about influenza, but it turns out that there's an excellent influenza surveillance system, but there isn't one for gastroenteritis. So if some public health organization, probably the CDC or something, would pay $100,000, we probably could track stomach flu, is an idea that I have to try to sell to people. So next steps, we're working on this study. It's called the Informed Consent User Experience Study. Again, I mentioned our internal review board. They require very specific informed consent scripts, and we're testing different ones to see how it affects the user experience. If people have expressed the concern that somebody could be calling like an emergency, like a suicide prevention hotline, and they get into our system and it causes something bad to happen, so you have to put in language to accommodate that situation. And then we're testing that to see how it affects costs and yield rates and stuff like that. So I have data that I haven't analyzed yet that we're going to evaluate the RICS IVR-to-CATI for representativeness and bias, like I did with the IVR data. I'm also working on methodology to optimally design data collection platforms that combine RICS, IVR-to-CATI, and outbound telephone. So depending on the relative bias in each one, there's an optimal way to combine it and the costs of each one. And so that's something I'm working on. I'm going to present that one at the joint statistical meetings this year. And that first bullet, the informed consent, I'm going to present at the APOR conference this year. So that is my talk, and I appreciate everybody that stayed with it.